Again, we're on time, so we can get started. It's great to have Bryana and Víctor here. They work at GitHub. They are both staff engineers there, and they work on the authorization team. And we're going to be talking about authorization at GitHub, and specifically its internals. But before we kind of like go down the rabbit hole, I want to talk to both of you and kind of like learn a bit about your path. So maybe Bryana first, then Víctor. How did you get over to GitHub? What have you been doing there? And what are you working on today?
Great. Yeah. Really excited to be here. I've been at GitHub for a little over 5 years. I came over, I was working for a small startup-like company, but we were owned by Aetna Healthcare. So we had the startup culture, but not the stress of raising funding, which was nice. But I've been on the authorization team at GitHub for about 3 years. Before that, I was working on doing some performance and scalability and data modeling work for GitHub's main Rails app. And I'm in Boston, Mass, East Coast of the U.S. And I live here with my husband and my dog. And I'm also active for the Women Who Code Boston chapter. So you can find us on Meetup if you're local. And yeah, great to be here.
It's great to have you here as well. And thanks for your intro. Víctor, do you want to kind of like share a bit about your background?
Sure. Thanks for having us. It's really cool to be here. I was born in the Canary Islands, Spain, and I've been doing software engineering for over 13 years. I joined GitHub in 2018, and since the get-go, I was doing identity and access management. The different iterations of the team. Today, I'm on the first team, and I'm based in Berlin with my family, my wife, and my kid. Dog and cat, and my free time I like to hit the drums with my hardcore band and do some music production, and I like to play video games, and I'm also really excited to be here.
Excellent, thank you. Yeah, we were chatting with Bryana before we started about like GitHub continuing to have that remote first culture as it continued to grow, right? I remember kind of like over the first few years at AuthZ, GitHub was kind of like a big reference in the remote first aspect, and we followed a little of what you did to kind of like model how we were thinking about the company. So let's get into like the topic of today's chat, which is like authorization at GitHub. The way I usually like to start these conversations, we're talking about a product, and it's great that you've been at GitHub for like a few years now, is to give some context about the evolution of the product before we're getting into the internals. Can you share a bit about the evolution of authorization at GitHub and how that has changed over time?
Yeah, absolutely. So I think the authorization at GitHub has evolved in line with the product itself, like you said. So if you think about GitHub from, say, 10, 12 years ago, it was really basic and simple compared to what GitHub looks like today. So back in the day, it was just users who were trying to collaborate on code together. And that was really it. And those
Hey, Bryana, are you still there? I'm hearing your audio, but it's a bit choppy. I'm not sure, Víctor, if you're hearing the same thing or it's just me.
Yeah, I think I lost Bryana as well.
Okay, let's wait for a few seconds to see if she comes back. Let's see. I don't know if she knows that we lost her though.
I think I heard something. Bryana, you there?
Okay, I think she's back. Bryana, can you hear us?
Can you hear me?
Yep, we can.
Yep.
Oh, sorry about that.
No, don't worry.
Okay, let me try to pick up right where I left off. So yeah, I think I was saying that GitHub, the authorization at GitHub, it kind of aligns with the evolution of GitHub, the product. So GitHub back in the day was really basic, just users collaborating on code. So the authorization model followed that really simple model where we were just needing to store relationships between users and the repos that they were working on. So we used a really simple, almost like access control list model between users and repos, and that was the extent of it because that was all we really needed. But as as time went on, we added more features, and we added organizations in particular in GitHub in 2010. So with that, we had to update the authorization model to support organizations, which also include teams within them. So we had a way to more easily map organizational structures to GitHub and reflect that in our access control management. So we enabled permission assignment for those user groups, and that was added into the model. So that was a big deal back in 2010 when orgs were introduced, and it wasn't just individual humans working individually anymore. So outside of users, we also evolved in terms of the product. So going beyond just repos and code, we added features like issues, pull request reviews, projects, GitHub apps. I know it's hard to think about this, but these things didn't ship with the original version of GitHub. So, as we added all of those different features, we had to kind of adjust our model, or at least like the semantics of the model and the value of the data that we were storing to support these different types of resources and the different groups of users that would have access to these resources. But we still kind of stuck with a simple model, right? It was just storing, ACLs essentially for different types of resources and different actor types being like individual users, groups of users, teams, orgs, whatever. So yeah, I think those were some big milestones for us. We have started, although we've moved beyond just users and repos, our access control model still has repo permissions at the core of it. So we still rely really heavily on like repo, read, write, and admin as our core roles at GitHub, but we have started to try to add some new roles and also break apart the permissions that were or continue to be implicit within those roles and enable like a more fine-grained permissions model as an option going forward. So this is I listened to the part of your talk with the Slack folks, and I feel like they're doing something really similar where trying to migrate from a coarse-grained permission system to a more fine-grained permission system to meet customer needs and make things more configurable and dynamic and have more options for our customers, but also be able to build things more fluidly internally in terms of new features and updating existing features. So yeah, we're still in that process. And so I think the biggest changes have been additions in terms of features, different resource types that we're supporting, and then also adding different kinds of users and organizations and enterprises that are on GitHub and being able to support all of that.
That's great. That's a very interesting recap, and I like how you mix the time aspect of things and like GitHub's product evolution with like the authorization systems evolution and feature set. So kind of like a quick recap would be, again, you started with the collaboration features, like who can, individual users that can read, write, maybe be admins of repositories. And then that was kind of like an ACL or access control list model. This user can do this thing on this repository, kind of like a triple sort of thing, I guess. And then that started kind of like evolving towards what we now have, which is you have the notion of an organization, you have the notion of like a group of users, but it's still an ACL, correct? It's still an access control list, just that you have kind of like a group and then members of that group kind of like get permissions from that group's ACL.
That's right, yeah. And then it's just like we still have repo as like our core subject type that we're granting access to, but we also have all of these other resource types that we like can create ACLs for. And like even our access levels have become more varied than just read, write, and admin. So that's kind of touching on the fine grain, the more fine grain piece of it that we're aiming for now.
Right, like I think there are roles like maintainer and triager that are kind of in the middle, and then
That's
there's
right.
a decoupling. Yeah, and there's a decoupling between like the role, like the reader, the triager, the maintainer, and its permissions, right? And I internally, I guess you start thinking more about like, does the user have this permission rather than does the user have this role, which implicitly means this permission.
Correct. Yeah, and like obviously the customer sees like read, triage, write, maintainer, admin. We like having more fine-grained permissions under the hood enables us to build permissioning for new features and update the permissioning for existing features way more easily if everything's broken out into fine-grained actions.
I see that makes sense, and this is a good kind of leeway into my next question, which is, so you have both the collaboration features that are authorization related, that you also have, I guess, more like the enterprise features, the compliance requirements, the notion for the projects, teams. How do you deal with new features in terms of like these two things? Do you work together with teams that are building the features? What does that evolution look like for new products or new features within GitHub?
Yeah, I can talk about this. You can see this as a spectrum. On one hand, we have the collaboration open source, which is at the heart of the product, and at the other end is the enterprise, which is also definitely important group that has very advanced needs of the authorization platform. And so we really want to meet them whatever they are in their life cycle. So from an authorization perspective, this means, like you can go from the simplest case, like a user-owned repository, to enterprises with multiple organizations, conditional access policies, very complex hierarchies, synced using SCIM, external collaboration. You can have your, behind doors your activity with private repositories, but then you can have your as your organization, your thriving open source community. But also, within an enterprise, there could be multiple organizations collaborating with it, within them, and via inner sourcing, using internal visibility. So yeah, I guess this kind of mature enterprises pushes our boundaries in terms of the authorization platform. And yeah, with respect to the teams and how we work with them, like what we want to provide them, the internal teams, is a platform they can kind of like self-serve and take these building blocks to create their features. So they're really the owners of defining what the business logic for their individual features looks like. We're really creating this this foundation for them to be able to do that in a secure, scalable, and productive way.
No, that's great. I think that makes sense. And we actually had a chat with some folks from Mercado Libre last week, and they also kind of like work on the authorization platform. So it's not necessarily kind of like a team implementing authorization for a feature, but rather like building blocks for other teams. Do you have different product managers for the different types of features? How do you know what to build?
Yeah, we work closely with internal teams, and they basically come with their requirements. We interview them to kind of understand how do we want to evolve the platform, the same platform, in order to meet their demands and their needs. And yeah, at the feature level, they will have the individual like product managers focusing on specific feature, trying to validate hypotheses and whether something works or not. We work, with our fantastic product manager, Jared. Shout out to Jared, awesome human being. We work with them. We collaborate. We gather insight from internal customers. But we also collaborate, or we listen to enterprises to understand what are the limits of the authorization platform. So we work both product teams as internal customers, but we'll also listen to to our end customers to understand what are the limits of our platform.
Yeah, that's great. Like that. Thinking of other teams as internal customers is, again, it's more and more of a trend, but it's always a big important challenge for platform teams. So it's great that you kind of like that's how you phrase the answer, and also kind of like how you started to think about that. Before we dive deep into kind of like the internals and the architecture, can we give the audience an idea of like the scale of GitHub? Because it's like all of us are kind of like familiar with the UI because we've used it, but like how many users are there approximately, right? And how many repos and how many organizations? This is kind of like to just give some notions of the scale that you all are handling.
Yes. So we grabbed some numbers for you. Right now, we have around over 65 million developers on GitHub. To give you a sense of activity based on that, they contributed 2.2 billion contributions in the last 12 months on GitHub.
Wow.
Yeah. We have over 3 million organizations, 200 million repos, which was a big milestone for us that we recently hit.
Congrats.
Yeah, thanks. So these are some big numbers, I would say. I was curious about what does this translate to in terms of like requests that we handle. And luckily, our CEO, Nat, was actually tweeting about this a couple of weeks ago. So I got some info from Nat's tweets. So it sounds like we are handling like 55,000 requests per second at peak for our API. For web, I actually had to pull this number, but it's around 20,000 requests per second at peak. And then for Git, what I could gather was about 2 billion Git operations per day. So hopefully that gives you a sense of our scale. And in my opinion, that's a lot. That's pretty big.
Yeah, it is, and again, like I know, again, at least I have this feeling at AuthZ, which is like I know how the system works, and I know how the system needs to improve. But like at least hearing these numbers out loud, like at least I would feel proud of being able to kind of like have a system in production that's handling that load consistently.
Absolutely, yeah.
What percentage approximately of those requests involve authorization, right? Is it none of them? Is it all of them? Is it 90%? Because like this is kind of like a big thing, right? Authorization is usually in the critical path for a lot of what you do.
Yeah. I would say it's, if I had to summarize it, I would say it's all of them. And there are some, so you're exactly right. Like authorization is in the critical path. So like you make a request to GitHub to API.com, like we have to know who you are, which is what more so what I would consider authentication. But then after that, we have to determine what you can access. So yeah, I would say every request to GitHub has to consider authorization. There are some like edge case exceptions, right, for things like marketing pages where we're not showing anything that needs to be authorized. It's just publicly available. We have certain endpoints for like metadata, like static pages, and then we can cache some public content at the edge. So those are the exceptions, but the rule, we authorize every request.
Yeah, that makes sense, and kind of like what I expect from what I've seen in the product. How does the architecture work? Maybe we can dig into a use case, like what happens when I add a person as a writer to a repository, and then what happens when they try to access that repository and maybe perform a write action. Can you walk us through that use case or that user story?
I can talk about this. I think, in a nutshell, an authorization decision at GitHub is composed of, access control policies and then, data coming from multiple sources. This data comes fundamentally from our ACL access control list table that lives in MySQL. So, for instance, when you grant, read, write, or admin permission over a repository to a user, that translates into an ACL. Making a user a member of an organization is another example. Team membership and team grants of a repository as well. So that would be the kind of like the permission side of things. But there's also another set of data that we consider relevant for an authorization decision. And so we don't have a better name for it, so we call it authorization relevant data because it doesn't have the shape of a ACL. And so, these access control policies, might take, aside from the ACLs, they take other sources of data and sets of data to compute an authorization decision, and it's necessary. This data is usually owned by the various feature teams that build the feature. So one example is the repository visibility. Repository visibility lives, close to the modeling of the repository entity in GitHub, and it would be impossible for us to define an ACL to say every user, we said 65 million users, right? Each one of those 65 million users has an ACL entry with every single public repository on GitHub. And so this is just one example of like the kind of data that also is relevant for business decisions. And so, yeah, in terms of like how the request, like the authorization request works today, the Ruby monolith still drives most of the authorization decisions. We've encoded these, policies as, a series of like, Ruby code that handles most of the coarse grain access controls in the monolith. And the repository continues to be the default level of granularity for most of the operations. And this is still true, across the three well-known interfaces that would be web, Git, and API. But like we also, we're moving also towards this world where we are, having more fine-grained controls. We want to also revamp. We've been working on revamping the authorization platform, and we are incrementally moving to a new authorization service with the goals of centralizing all the authorization logic. Providing more flexibility to our internal platform, internal customers. Also very important here is to expose the authorization logic to the service architecture, to the microservices at GitHub. And, in general, just to define this kind of lingua franca to avoid reinventing, to make sure that teams don't have to reinvent the wheel and end up with bespoke solutions. So yeah, depending on like, how it's up to the individual feature teams to define how that works. How like whether they want to choose and go with like the old school coarse grain permissions and reuse what's in place for a long time, or they want to take advantage of the more advanced functionality that we provide as part of the platform. And so it's depending on the individual features, in the request path might look like different. It might end up just in the monolith and be handled by the Ruby code, or it might trigger an RPC call to the authorization service that would match a series of policies and evaluate a series of rules in those policies and come back with a authorization decision. And yeah, go ahead.
No, I see that makes sense. It's an evolutionary architecture. Like most successful systems have, kind of like nothing is in a complete finished state. It's mostly in flux.
Yeah, I think it has evolved, as Bryana said, with the product, and as the need arise, we need to evolve the system to meet our customers. And so yeah, it's in this intermediary step where we're moving from, and I expect it's gonna be around for a while, and it will continue to evolve. Like we will discover new use cases that we didn't anticipate. That's how it works. Something I didn't mention is like the persistence side of things. We started with a monolithic database for everything at GitHub, and then as we started to hit the limits of vertical scaling of a single primary, we went for functional partitioning of that database. So today we have lots of different MySQL clusters that serve functionality from different bounded contexts. We refer to those as schema domains. And the ACL table that I referred to early on, it's living very comfortably in its own database cluster with enough headroom to support today's load. We consider the tests, to scale on writes, but back in the day, but at that point, the operational maturity wasn't ready, and so as such, we basically optimized the ACL model for for writes, so with a very heavily normalized model, so that basically we just rely on scaling on reads, which is by basically adding new MySQL replicas to the cluster. And yeah, but Vitesse is seeing a lot of adoption these days at GitHub, and it's already in production for some critical parts of the site. And it is definitely a key part of some of the explorations we are doing to continue to evolve the authorization platform.
I see, that makes sense. So my take on this is like there seem to be kind of like two big pieces of this. One of them is you are coming from a place where the monolith has this sort of like chain of responsibility pattern that goes read some data from the database. This data might be ACLs from the ACL functional MySQL, but it might also be things that it needs to make a decision like, is this repo public? So kind of like a mix of ACL checks and attribute-based control. And then you're moving towards kind of like the authorization service, which might have similar logic, but you're trying to kind of like decouple that into a separate service and have the notion of like these policies. Is that accurate?
Yeah, that's exactly right. I think, internal developers, they made use of like the ACL for permissioning, but also then they had sprinkled all these different checks in the code base, also for like these things that were not necessarily a permission. And so what we want to do, as I mentioned earlier, like the goal was to centralize all the different authorization checks so that there was just one single canonical place for each feature to define what the authorization looked like and define this kind of like physical boundaries, because it's very easy to cross boundaries within the monolith and start like joining against tables. And we've been putting measures in place, also to make sure that, there's a boundary for the ACL table. And for the old school coarse-grained functions. And so the moving to a microservice was really compelling for us because it introduced this kind of like physical boundary that wouldn't allow this kind of like anti-patterns that we saw and when we were just running a monolith. Today, there's a lot of microservices at GitHub, so we are definitely chipping away more and more functionality into microservices.
I see. That makes sense. So you mentioned kind of like the goal is to go towards this authorization service architecture, centralizing authorization decisions. And something that you mentioned a couple of times was like this kind of like decoupling and like creating a boundary. Now, a lot of those things make sense to me. I'm thinking about this. We've talked a bit before, but maybe for the audience, what are the things that you're hoping to either prevent or get as a benefit from having that separate boundary, that separate centralized service?
Bryana, you want to talk about this?
Sure. I mean, I think there are trade-offs that come with putting authorization in a centralized service that's outside of the monolith. Like the reality is that like most of our core operations can happen with requests to the monolith and not in our database, and that's about it, right? Like we have services, but we are not by any means like fully a microservice, like service-oriented architecture. We have a legacy old like monolith that we are starting to break out specific functionality, but we're super intentional about what we break out, and it is few and far between that we like build outside of it. So that said, I think the big advantages of creating an authorization service outside the monolith is scalability. Like we can scale that service independently from the monolith. It's developer productivity, right? Like the monolith has literally thousands of developers working inside that code base every single day. So being able to iterate and deploy and work separately from that enables us to work faster and more efficiently. I think from a performance perspective, like we are still querying the same database as we would be querying from within the monolith, but we can use, our authorization service is built in Go, so we have the niceties that provides in terms of a performance perspective as opposed to Ruby. I think another really compelling reason to build outside the monolith for the authorization service is that, like, although we don't have lots and lots of services, we do have more services cropping up every day. So we need to have a way for those services to get this information, and a lot of those services do not want to be coupled to the monolith for the same reasons that we don't want to be either, like namely performance and scalability, reliability, things like that. So yeah, I think those were the reasons that we made this choice, and I think we stand by them.
Great.
Yeah.
Go ahead, Victor. Sorry.
Yeah, I just wanted to add that I think decoupling the failure domain is also really a strong, compelling reason here, right? If we have services that start to expose interfaces to the outside world, like packages, and so like they want to minimize the contact surface with a monolith, and being able to rely on on authorization service and authentication service, and being able to have that decoupled failure domain, and being able to continue to be up if something is up with a monolith is a really strong compelling reason for many internal teams.
Yeah, that makes a lot of sense, and I really like how you both kind of like are able to almost enumerate as if they were bullets the benefits, and it's good to go back from this is the tactical way in which we decided to kind of like go get those benefits, but make it clear that a lot of these things are about the business, right? Like scaling independently probably is making you save money and also improving your reliability, the productivity aspect. All of those things are important beyond the technology of the service itself.
It also comes with its challenges, for sure. Like you sometimes have to pave the path to how things work because no one else has done it before you at the company. But in general sense, I think it's a net positive for us, for sure. There are things also, like, as you mentioned, developer productivity. Like we don't have to be subject to the kind of like deploy queues of the monolith, and we can, deploy faster outside of the monolith because we don't have a long queue of folks that also want to do the same thing in front of us.
Yeah, we go through similar things at AuthZ as well, where we also are kind of like pulling different parts of the original code base out over time, but you still have that natural kind of like contention both on deploys and also kind of like pull request merges and things. So it makes sense from that perspective as well. One of the things I'm wondering about is like a lot of the permissions that GitHub, the product, has seem to be, and this is kind of like my understanding, correct me if I'm wrong, about like the product, right? So for example, the notion of an issue does not exist in Git. But it seems that there are some permissions that are Git specific, like the ability to create a tag, for example. How do you deal, if you do, with Git specific permissions, where the protocol itself might not have a plug for authorization, but you still want to allow your users, your customers to have authorization for those features?
I can take this. So we don't have, like the Git operations that you'll do to interact with GitHub are still mapped to repo, read, write, and admin. So it's actually the most simple like mapping, because if you're trying to pull a repo, you can that just maps to repo read, and then pushing comes with repo write, and we consult that data, that permissions data, when those operations take place. There are like some nuance in terms of like Git actions that you can take, like creating a tag operation, like branch protection rules. These kind of follow the same breakdown that we're trying to do. So we may have specific fine-grained permissions for these that map to like a role or not. And then we also, under the hood, they just might be like implicit in terms of an ACL that we already have, like implicit in repo read write or admin, implicit in like org member or admin. So yeah, I would say like these operations kind of follow the same patterns that we have already in place for all of the other access control that we do on GitHub. So yeah, like I think this all goes back to like breaking things out into more fine-grained. And like we obviously would like to enable more fine-grained permissions and be able to put those into different roles and make everything more configurable and more customizable for our customers. And we are like in the process of doing that. But everything that we've already described kind of covers those actions as well.
Okay, I think that makes sense. You mentioned the word kind of like more granular permissions. Can you maybe provide an example of how you at GitHub think about granularity? And also, what are the challenges of having to support a granular system over a, I guess, more coarse-grained one?
Yeah. I think in terms of what level of granularity do we think about, I think we still ask ourselves that question a lot. Like what is the right level of granularity that we're aiming for? Ultimately, our ideal world is that this is up to the feature teams that own the features that are requiring these permissions, right? So like recently we had an example, like new GitHub discussions. Like this is a brand new feature that didn't really exist on GitHub before. So that team had the ability to go and write the rules around discussion authorization, right? Like, do they want to fully rely on repo, read, write, and admin, or do they want to make things more flexible for their customers in terms of managing discussions and interacting on discussions? And also, like, discussions aren't necessarily just tied to a repo, I don't think. I could be wrong about that. But like, there are resources now that exist that aren't just like issues and labels, pull requests, those things are all repo centric, but there are projects and packages and resources that don't off of a repo. So in those cases, I think turning towards fine-grained permissions is a good option. And then it's up to the feature teams and the product managers and the business to determine, like, what do we want to allow in terms of granularity? Like, do we want fine-grained permissions that's just managed discussion, and that would handle all of the settings, all of the security aspects of discussion administration? Or do we want to go to the level of granularity of delete discussion, block discussion participant? You know, like, you can go super granular and you can go less granular, and it's ultimately it's up to the feature teams to make that decision. But yeah, so that's just an example of one question that we grapple with. I think we think about that in terms of a product, but we also think about that in terms of scale, right? So if we enable any feature to have unlimited fine-grained permissions, what's that going to do to our database? Is that okay? And like, so it's a balancing act of like what makes sense for the product and what makes sense for us in terms of engineering and scalability. And other questions, I think this is the big one. How do we evangelize a large engineering organization like GitHub to move to this like fine-grained permissions model and kind of break down these coarse-grained permissions? Like, within these coarse-grained permissions, there are so many implicit actions that you can take, and realistically, like, we as a singular authorization team of less than 10 people cannot go through and break out everything, right? So this has to be a large effort. And so, you know, right now we work with teams that come to us, or we reach out to teams and say, hey, like, maybe it's a good idea to move to this new model. Here are the benefits. What do you think? What are your needs? And that's a conversation that we have. But yeah, like, we're always thinking about what's the next right thing to do in terms of pushing this model forward and having it be adopted successfully by all of these internal teams at GitHub.
Yeah, that makes sense. How does that like interaction work? Let's say I'm a feature team and I say, hey, these are the permissions I need. Is that a self-service internal thing where they can just go and dynamically create those and then they will be available to query and for policies? Is there a discussion that happens with you and the team? How does it work?
Yeah, that's an interesting question. I think, you know, we start with like this sets of building blocks that we provide to internal teams. The platform. We have frameworks, we have libraries, and we have, you know, APIs. You know, as Bryana said, teams define the authorization logic for the features, you know, and they're powered by our platform. So they start by defining, you know, what should the authorization model for our feature look like. Yeah, Bryana mentioned like the GitHub discussions example, you know, like we provide them like ways to define permissions when they need, ways to grant permissions, and mechanisms to like define the logic and evaluate it. And so, for instance, they might decide to go, you know, hey, I'm perfectly fine living with a traditional coarse-grained model, and they can decide to use the the functions that we provide to determine whether they have the access control list, whether they are read, write, or admin. There are a set of reusable functions in the monolith, and if that works for them, great. If they want more advanced, they have more advanced needs, they might want to define perhaps a fine-grained permission. We define fine-grained permissions in a declarative way, and developers might decide, whether they want to assign this to, a base role. These base roles are the coarse-grained roles that we all know in read, write, and admin. But they also might decide to use those fine-grained permissions to assign them directly to users. And so we have a scenario where like a user might be having a write on a repository, but also they've been assigned package manager at the organization level via a fine-grained permission. So when they're happy with kind of like the modeling of their fine-grained permissions, then they start defining the policies, which include the rules, and they also do this declaratively. And they register their policy with our service, right? And so policies evaluate any arbitrary data. We follow the attribute-based access control. I guess I call it architectural style. I don't know what would be the right name for it. But yeah, basically, any pair key values can be passed to the authorization service, and that might be, or also retrieved by the service itself to compute authorization decisions. And so, yeah, the policy will contain all these different business rules to evaluate whether they are allowed or denied to perform a certain operation. So when the policies are ready, they're deployed and they're available as part of the service, then it's time to perform the checks via the APIs that we provide. We expose a Trip API, and to consume it, you might want to use one of our libraries, Go or Ruby libraries that we officially support to talk to our APIs. Or if you're building a language that is not Go or Ruby, you can always talk using JSON, because Twerp supports also JSON content. And yeah, the API call looks with a very simple, can this actor perform this operation over this resource? We think in terms of operations over resources. We don't think in terms of like, does this user have this role? And this is fundamental to go to a fine-grained model.
Yeah, that sounds. Oh, sorry. That sounds very similar to like ACL checks, but also kind of like the Zanzibar model that is growing in popularity, right? Can this user perform or has this relation to this object?
Exactly. We have examples like can this user close this issue, which is actually a fine-grained permission under the hood, or can this user view notifications, And so yeah, we try to steer internal developers to start to think more in terms of operations and less in terms of like, can this user can do this because they have this role.
Right.
We wanna make sure that we remove roles from the equation. More of the roles are composed of permissions.
Right, like the code becomes, instead of having a comment that says admins can delete repositories, and then if this user is an admin, then delete the repository, it's just if this user can delete repositories, then go delete the repository. A bit more explicit, so to speak.
Exactly. And then at the product level, product makes a decision whether they want to, I'm going to assign this FGP to add the admin role, or to the or the admin, the right role. So that's something that's definitely possible.
Makes sense. You mentioned policies. What's the policy runtime? Is that something you built? Is that an open source technology?
Yeah, we started an MVP. We started investigating about like how did we want to provide a flexible model for our internal customers. They always came with this requirement, like, yeah, we want to be able to model anything, because like you could define any kind of new feature on top of the GitHub business domain. And we even had requests from infrastructure, like I want to also be able to have an API that supports authorization within my Kubernetes clusters and things like that. And so we look at it, and I think Matt Todd is online also in the call, and Matt Todd and I, Bryana, and James, shout out to James. We were working in 2019 on defining what this could look like, and we came up with, hey, this AVAC pattern looks very interesting. It could work for this scenario. So we built an MVP within the monolith. We built an MVP of the Authorization Service in the monolith, and that came with a policy language, which is serialized as JSON, and a parser and interpreter. And so yeah, within a couple of months we had something working, and we shipped it with we supported some functionality. And so once we validated our hypothesis, this seems to work. This seems to be powerful enough. Then we moved outside and we rebuilt everything on with Go basically, following the same fundamentals.
Okay.
So yeah, the developers will basically define these policies declaratively. They use JSON files, and they will register them within the service. And then when requests come, basically the engine will on runtime decide, match policies like given the attributes that you're passing me, the context that the environment and the context that you're giving me, like what are the policies that make sense in this context. And so the engine will look at all the policies we have, and we'll try to match what are the policies that make sense for that request. And once the policies are matched, then it goes into the evaluation phase, where basically it starts to evaluate the different rules that it has, and it comes back with an allow or deny. We also have other kinds of responses, like perhaps the request you sent doesn't make sense. I don't find any policy that makes sense to what you sent, and so we return something like not applicable. But also, if there's an error while evaluating the policy, we might also return, an error back to the client.
Okay. Can you share maybe like a use case for like how a team might create a simple policy and how it's used? So for example, again, when does a team say, I want to use a policy over I can just deal with the permissions directly?
I think that we want to steer them to do this because we think it's the right way to go. I think, back in the day, we look at all the problems we had and we concluded, hey, we centralize all the logic. We want to have everything in the same place, following the same rules, following the same language, the same patterns. We want to make sure that they use building blocks that are battle proven and that we're not reinventing the wheel, and we want to make sure that they don't make mistakes while building the authorization logic. And so having this kind of like lingua franca and centralized, we thought it was a better approach but we cannot prevent today that they will go and do things the old school way. So I think that generally people come to us when they are in need of the more advanced functionality that the service provides, and also people are really keen to follow the recommendations because they trust our judgment, and they trust that we are recommending the best practices to do authorization. And so I might have derailed a little bit. Your question is like how would like the developers come and like create a new policy and contribute to the service? Was that the initial question?
So let's say I have a request that's wanting to like check for access. First of all, it's like, how would a developer format a policy document? We mentioned it's JSON, but like maybe what does a simple policy look like? And then as the request comes into the authorization service, we talked about the authorization service decides which policies apply based on the context. Where is that data stored, and how does it make that decision?
Yeah, so the payload of the request comes with key values. It's attributes, right? And these attributes usually come with, we provide the very minimum information that we need to compute this. And we want to do this because we don't want to couple the client side with the internals of the policy. The idea of one of the benefits of AVAX that you might be able to add or evolve the policies, and you don't necessarily need to change the client side call, right? And so you provide the basic information. This actor is performing this operation on this user. So I will have an identifier for the user. I will have an identifier for the resource that's being accessed and the type of resource that it is, and then the action that it's being performed. And so in the server side, a policy basically, it's composed of like a match clause and a rules clause. And so the match clause basically is I wouldn't say it's a full-blown like imperative language, declarative language, but you can basically do all sorts of like, is this value equals to this, and equals to this, or equals to this. And so based on that, you can basically look at the attributes that come as part of the payload and say, if you're saying that the user is closing an issue, then I'm going to identify those attributes. I'm going to check them against my match clause and say, yeah, this policy seems to be the right one for this request. And once we've evaluated all of them, you might end up with one or more matched policies. You basically take the policies that matched, and then you execute the rules, which are exactly the same language that you use for the match clause. And so when it comes to the data retrieval, you might provide data as part of the request. And that's what we use for the matching of the policies. But then on the rules section, we actually instruct, we tell the engine, also in a declarative way, we register attributes. We define attributes and say, this attribute means this, and it can be resolved this way. And this is also a pluggable system, but 100% of the resolution, we call this attribute resolution, ends up in a SQL query to one of our clusters. And so the engine will evaluate all these attributes. If it's not part of the request, then it will try to find if there is a resolver for it. And if there is a resolver, it executes and performs the query.
That makes sense. And thanks for kind of like going into the details of, okay, we take some of the context of the request, we match through the policies, and based on those, we pick the ones that apply, and then we kind of like execute them. We also talked about like the MySQL database again towards the end. And one of the things we had discussed earlier is how it's like there's a dedicated functional MySQL cluster that's specific for the ACL data. It basically grows in terms of like read capacity by adding more read replicas. How do you keep growing the authorization set of features as GitHub continues to grow, both from a scalability perspective? What things do you do to kind of like keep the system reliable? How does that work on a day-to-day or maybe quarter-to-quarter basis if we want to go towards longer timeframes?
I can chime in. So yeah, like you got it right. We have, for our primary permissions data, our ACL data, we store that in its own cluster, and we are able to scale that, just like expanding the number of replicas. Beyond that, like there is other data that is relevant for authorization decisions that we've talked about, this authorization relevant data. That data we have less control over because it's normally coupled to a feature or like part of the product that isn't specific for authorization, right? Like repo visibility is owned by the repos team. Other examples are things like security settings or spamminess of a user. Like these are things that we need to take into account for authorization, but we don't own that data, right? We just read it. So in that case, it's just that data is scaled in the same way that we scale all of our data for GitHub. We have an amazing MySQL team that is able to maintain our clusters in a healthy state, to monitor load and let teams know when they're about to, be at capacity or they're experiencing issues. And I think as a company, our strategy has been to like shard when we need to, using vtests, move things into different clusters. If there's too much load in a single cluster, we split things out. So yeah, I would say like a lot of this is not specific to authorization per se, but just like how do we scale MySQL at GitHub, and that's kind of the approach that we've taken. In terms of like scale our usage, like our authorization service usage is still relatively low, and we're able to scale that out as needed basis. And I think we're always looking for optimizations that we can make from like the application perspective as well. So like, for example, during policy evaluation, we try to optimize those policies such that the attributes that are evaluated early on are the cheapest ones, or the ones that are most likely to return something that would mean that we can bail out of the policy evaluation and return an approve or deny. So like that's more manual and less on an infrastructure level, but there are definitely like application level things that we can do to make sure that we're optimizing as much as possible to make sure that authorization is fast, because it is in the critical path. So that's really important for us.
That makes sense. And so like taking kind of like some of the things that you're saying around like latency, there's a part of that that's like making sure that's a good customer experience. I know that also GitHub has lots of clients, right? Like GitHub for Windows and for Macs, there's like a CLI. What do you do to improve the UX for those clients? Do you do any caching at the edge? Do you do any caching in clients?
Yeah, I can't really speak to like the architecture of those clients. We have teams dedicated for that, and ultimately it's up to them to like design those clients in the way that is the most optimal for their performance and their UX. What I can say is like those clients are like, most of the time the rules of any integrator also apply to those clients. So they are at the mercy of our, or like have the advantages of our public GitHub APIs to power them, the same as any other integrator has. In terms of like caching at the edge, we do cache at the edge. We have lots of points of presence around the world so that we are closer to our customers and we serve content as fast as we can. But yeah, again, nothing super authorization specific about that.
Okay, thanks for sharing that. Maybe going back to kind of like the internals, again, we talked about some of like the application level things that you can do to improve latency, the scalability of MySQL. Again, not authorization specific in terms of what was built, but yes, in terms of like how important performance and latency is for authorization. What's the business impact of latency? What happens if authorization is slow at GitHub, for example?
Yeah, I don't think I would add anything new if I say that faster means more engagement and conversions. I think that's universal in the webs. But yeah, the performance is definitely very important focus for our work. And you know, as you said, I think everybody knows that authorization is in the critical path. And if it's not performant, it can slow down the whole application in a more noticeable way than other parts of the system. Perhaps it has this kind of like compounding effect. And so, yeah, it's definitely important, and we're always keeping an eye on like everything. We have definitely a really in-depth observability stack, and we do various techniques to like reduce the impact on the overhead of requests to the service. So we do things like kind of almost like request hedging, so that we wait for a request to come. We issue a request, and if it doesn't come within a certain amount of time, then we issue any request. Another interesting technique that we do in the monolith, because it has its own set of restrictions when we are building things in Ruby, is request batching. And so we basically use promises to defer the execution of the authorization checks, until the last moment, essentially. And so when the promise is resolved, then we can send all these batched requests, individual requests in one single RPC call to the server. And what is interesting about this is that we can do concurrency that we cannot do in the month, because when the batched request hits the server, we basically found out using Ghost concurrency primitives, and we resolve each one of the individual requests in that patch concurrently. And so essentially we can do things faster than we couldn't do in the Ruby monolith. And yeah, I think an example I saw recently, I think I saw some requests to the site seeing 10 or 1,000 of RPC calls to the service, and then they turned, after doing some refactoring around, we turned them into a 1 or 2 batch requests. And so you eliminate the overhead of the network, which is relevant for sure, but more importantly, you're able to do more things concurrently. Yeah, I could think also, I think Bryana mentioned, things like, local optimizations on the policy, bailing out in the evaluation of a policy as soon as you possibly can. But also exploring in the future, doing even more stuff concurrently, like concurrent or speculative policy rule execution, like evaluating rules even before they actually need to be evaluated so that we have the results when the time comes. Essentially just reduce the amount of time that we spend waiting for the authorization service to come back to us.
That makes sense. So it seems you and the whole team spend a lot of time thinking about performance and latency.
Yeah, for sure. Like it was a really important thing, and I think our SLOs these days are 4 nines of availability over the course of a day, and 30 milliseconds on a P99 also over the course of a day. And with techniques like request batching and also request hedging, we've even managed to sustain 5 nines and peaks of 6 nines in some days. So yeah, we added a lot to make it possible to be really reliable and performant, and we will continue to do more work in this sense.
That's great. Like hitting consistently hitting those 5 nines on the 30 millisecond P99 is probably hard and takes a bunch of work. So good job.
Thank you.
One of the things we've been talking about is like the importance of this feature working, and also not just from a reliability perspective, but also like when you make changes from a security and compliance perspective, you want to make sure that what you're doing works. How do you make changes to policies, and how do you make changes to the authorization service? What things do you do that might be particular to these components?
Yeah, it's a good question. So I think authorization, like you said, it's so critical to get it right, because if you don't get it right, it's not just a bug, but it's potentially a security vulnerability. So some things that we use both in the authorization service and in the monolith, we rely on what we call science or scientists. It's actually open source, but the idea is that we can run an experiment to compare the correctness and the performance of like a control code path or query or anything that can be executed and a candidate. So if we're trying to make a change, we can introduce the update or the new code as the candidate and run an experiment to compare that against the control. So we can do this before we roll out the change and to give us a high level of confidence in terms of the correctness. So for a policy, for example, we want to ensure that a new version of an attribute is returning the same result as an old version of the attribute, or the whole evaluation of a policy is returning approve or deny for this a single request in the same way as the old one. So we can use science for this. We also have implemented policy versioning. So you can create a new version of a policy with the same matching attributes and either target the new version explicitly from the client, or you can have both versions match and then use that to safely roll out a change. So yeah, these are some tools that.
Oh no, we lost Bryana again.
I think we lost Bryana again. So a couple of notes there are, I think the library Bryana mentioned is, so GitHub scientist, there's a very good blog post for listeners out there from Zach Holman, who worked at GitHub. It's titled Move Fast and Break Nothing. And there he explains kind of like how GitHub used this library. This is from back in 2014, but it seems a lot of those concepts are there. And there's also a great post from Cindy Sridharan talking about like testing in production the safe way. And she also talks about this kind of like shadow deploy model. And it seems kind of like this is the technique that you are using, but at least for the general changes. And then like the policy versioning gives you kind of like both history and the ability to do sort of green-blue deployments for routing traffic at the policy level. Is that accurate?
Yeah, that's exactly right. Like we can do both sciencing on the client side, using this library, but the policy language also has baked into the language. So you can basically science portions of the rules of the policy. And yeah, I think we do extensive use of sciences at GitHub, and other and even more the authorization team, I would say. So we are really into making data-driven decisions, for the correctness and performance, and yeah, and then on the policy side, when it comes to changing it, we do policy versioning. Also, both, I think in the client side, we also rely a lot on feature flags, which is a really common technique for, slowly like gradually rolling out things. So we always start rolling things out just to staff members in the hovers, so we can actually, we try out our own functionality first. And so if it makes sense, then we start rolling it out to the rest of the world.
That makes sense. Who can approve policy changes? Is that the developer on the team, the author? How does it work?
Yeah, we don't have a strong policy in place to who can change the policies. So basically, each individual team is owner of their own policies. But the cool thing of the centralized thing is that if we want to introduce more processes into the how what does it mean to change a policy, we can actually do it. So that's kind of one of also the design choices of the Authorization Service, being able to introduce this kind of compliance rules and auditability when things in terms of when the policies evolve.
Makes sense. Bryana, do we have you back?
Yes.
Okay,
I
great.
switched headsets, so hopefully this one will stay connected.
That's okay. So kind of to wrap up, one of the things I usually ask guests is, what are your key learnings from working on this team? So just maybe take turns, but I'd love to kind of hear your main takeaways based on your experience working on platform authorization at GitHub.
Yeah. I think my key learnings and takeaways, I feel like there's a couple really big ones. One of them is that the importance of providing, especially at the scale that we're at as a company, providing a platform for authorization as opposed to trying to have a single authorization team responsible for all of the ins and outs of the product and the business logic for all of authorization on the product, right? It's just simply impossible to scale from an organizational perspective with the authorization team being responsible for writing all of the authorization rules for the site. So the way that we've handled that is switching from thinking of our customer base as external customers to thinking of our customer base as internal customers and namely other feature teams that want to build things on GitHub. So if we can accelerate them and we can solve authorization for them or give them the tools to solve it really easily and efficiently for their use case, then that's going to pay off so much more so than if we were trying to do everything for every product and feature on GitHub. Honestly, I think it took us a while to realize that, maybe too long to realize that. We were kind of in this hybrid model for a while of working on user-facing and customer-facing features and also trying to build out this platform and this service and these APIs. And we still do a little bit of both, but we're very much more so focused on the platform at this point. And I think that's the right combination. I think another takeaway for me, and this is my last one, is that authorization is in the critical path, and it is so if authorization isn't working, if it's slow, if it's buggy, it has such a big impact. It's a huge blast radius. So taking the time to think about the right architecture and roll things out carefully, and it's worth all of that effort. It's not just about getting things out the door, because there are so many implications and there's such a huge impact of authorization for every request. It's just really worth it to do the due diligence and make sure the engineering work we're doing is sound. So yeah, I'll let Víctor answer. I'm curious to hear what he thinks as well.
Yeah, I think you summarized it very well. I feel the same way. I've learned a lot of things in this team, not only from an authorization perspective, but at the human level, and how to work with distributed teams. But I guess, yeah, you summarized it very well. I think I am also on board with the video, empowering developers, how important it is to have a fantastic developer productivity to accelerate internal teams. That's really our goal as a team today. And yeah, it took us a while to figure out, but this is the right path for us. And I think it's something that every organization throughout their life cycle at a certain size, they will reach the same conclusions. Like, we need to build this kind of platform. We need to stop reinventing the wheel over and over. So yeah, I guess, I am reminded on a daily basis how, nerve-wracking authorization can be, even though I've been doing this for a while. It's definitely a really challenging space, and I guess I ended up doing IAM kind of like by chance. I really liked the team and my previous job that I was doing IAM, so I joined them, and then I discovered this space, which was so exciting. So it's a really, really challenging space, and it's really interesting from my engineering perspective. I guess something else to add would be, like, authorization is so critical. Bryana said it so well. Like, we really rely on numbers. We make data-driven decisions, and we're conservative with our like how we roll changes. And yeah, if you don't have the numbers to support the change, just don't roll it out.
That's great. I really appreciate both of you kind of like giving very detailed answers, and it sounds like you enjoy what you're doing a lot. So it's always good to hear that from other people in the industry. The other thing is, again, I want to thank Víctor. I want to thank Bryana a lot for, like, again, their time. We spend a lot of time kind of like via email also coordinating this, so really appreciate that. A couple of notes for everyone in the audience. We're wrapping up. Later, either later today or tomorrow, we're going to be publishing the recording. In case you missed some part of this, we're going to be making this available on YouTube, the audio, so that you can look at that, and you can also listen into the previous conversations that we've had with other people, other industry experts. And also next week, I think it's Wednesday, we need to publish the new Twitter card, but next Wednesday, we're going to be talking with David Brozard. He's been in the IAM industry for a while. He is an editor of the XACML spec, that's XACML. And we're going to be doing a very interesting conversation around, like, the history of authorization in software and the state of it in 2021. So hopefully you'll tune in and be able to listen into that one. Thanks a lot, Víctor. Thanks a lot, Bryana. It's been a pleasure, and I really appreciate you being part of this.